Daring Marina YouTube channel. Today we will be discussing about thrust bearing, their working principle and where it is located inside the ship. So let's discuss on this topic in a detail. Thrust bearing. So the principle is if the direction of rotation is reversed, then propeller will generate a thrust in opposite direction and ship moves in an astern direction. So the propeller blades should be set at an angle. Okay, means if the direction of rotation is reversed, then propeller will generate a thrust in opposite direction. If the direction of rotation is reversed, then propeller generates thrust in opposite direction. So the ship will move in astern direction. So that for the propeller blades should be set at an angle. Here we can see thrust force. Thrust will be equal to force into cos theta. Okay, higher velocity flow gives lower pressure. That means propeller thrust also increases. Okay, the aft end of ship, water ahead of the propeller blade. Ship in front affect the water flow over the propeller blade. Okay, what are the aft end of ship? Water ahead of propeller blade. Ship in front affect the water flow over the propeller blades. Okay, aft end of ship, water ahead of propeller blade. Ship in front affect the water flow over the propeller blade. Shape of blade is like an aerofoil. Shape of blade is like an aerofoil. It will increase velocity of water at top of blade. So the velocity of water will increases at the top of blade. The shape of blade is like an aerofoil which increases the velocity of water at top of blade. And this reduces the pressure at back and exerts greater pressure on the front face of propeller. So due to this shape, they reduces the pressure at the back and exerts greater pressure on the front face of propeller. And this pressure difference will generate force perpendicular to MEHG of the blade. Okay, this pressure difference will generate a force perpendicular to the blade. Okay, the axial component of the force exerts thrust on propeller shaft. So the axial component of force will exert a thrust on the propeller shaft. The thrust block is mounted on the shaft that transmit the thrust to ship hull. The thrust block that is mounted on the shaft that will transmit the thrust to ship hull. Okay, aft end of ship, water ahead of propeller blade. Ship in front affect the water flow over the propeller blade. Then shape of propeller blade is like an aerofoil which increases the velocity of water at the top of blade. This reduces the pressure at the back and exerts greater pressure on front of the propeller. Okay, this pressure difference will generate a force perpendicular to the blade. Axial component of the force exerts thrust on the propeller shaft and thrust block is mounted on the shaft and transmit thrust to the ship hull. Okay, operation means casing of the independent thrust block is in two halves. That means these each fitted bolts join the halves. Okay, casing of the independent thrust block is in two halves and fitted bolt join the half. Okay, thrust pad which pivot around the thrust collar, their surface carry the thrust load. Thrust pad means which pivot around the thrust collar surface, they will carry the thrust load. The pads are mounted in the holders and coated with a white metal. The thrust pads are mounted in a holder and they are coated with a white metal. Okay, operation means the casing of the independent thrust block is in two halves and they are joined, fitted bolt join the halves. Okay, thrust port which pivot around the thrust collar, the surface, they will carry the thrust load. Thrust pad which pivot around the thrust collar, they will carry the thrust load. And these thrust pads are mounted in holders coated with a white metal. Okay, here we can say thrust pads, thrust collar. Here we can say oil deflector, casing, bearing and oil bath in the down, aft and forward direction. Okay, oil deflector, they will deflect oil fitted by the thrust collar and directs the oil onto top cover. Here oil deflector from the name means it deflects the oil fitted by the thrust collar and directs the oil onto the top cover. Oil from the top cover cascades over the thrust pad and bearings and fall back to sump. The top cover acts as a pad stop. Okay, oil from the top cover cascades over the thrust pad bearing and fall back to the sump, and top cover will act as a pad stop. The thrust shaft transmits thrust onto the thrust collar. The thrust shaft will transmit thrust onto the thrust collar. Okay, here means oil deflector will deflect the oil fitted by the thrust collar and directs oil to the top cover. Oil from the top cover, they will cascade over the thrust pad and bearings fall back to sump. The top cover acts as a pad stop. And thrust shaft, they transmit thrust onto the thrust collar. Here we can see fixture housing, tilting pad will be there, pivoted and oil, thrust collar and all. So hydrodynamic fluid, their film wedges separate the thrust pad and thrust collar. That means hydrodynamic fluid film wedge, they will separate thrust pad and thrust collar. Thrust pad transmit thrust to the lower half of casing. The thrust pad will transmit thrust to the lower half of casing and lower half of casing is connected to ship hull. Lower half is connected to ship hull and ship moves when the thrust is transferred to the ship hull. The ship will move when the thrust is transferred to the ship hull. Okay. Here there is hydrodynamic fluid film lubrication. So, we will separate the thrust pad and thrust collar. Okay, thrust pad transmit thrust to the lower half of casing, and the lower half of casing is connected to ship hull. So, the ship moves where the thrust is transferred to the ship hull. Okay, these are all related. Okay, we can see the picture of a thrust bearing and all, propeller shaft assembly and all. Propeller stern tube is nearby this, then tail shaft, after peak bulkhead is there. Near the propeller there will be outboard seal, stern tube bearing will be there near the after peak bulkhead, then inboard seal will be there, outboard seal will be there, inboard seal near the propeller, and inboard seal near the after peak bulkhead, outboard seal near the propeller. Then intermediate bearing we can see, then we can see intermediate shaft and journal bearings are there, thrust shaft are there, thrust block are there, and flywheel, and towards the, that is after the main engine we can see flywheel and main engine. Okay, what are the construction and working? Okay, at aft portion of ship we have propeller and then propeller shaft which come inside the ship through a stern tube bearing. Yes, aft portion of ship, or the back side aft portion of ship, we have propeller and propeller shaft which come inside the ship through a stern tube bearing. Okay, there is an intermediate shaft. The intermediate shaft will connect propeller shaft and crankshaft. Okay, intermediate shaft is there which connects propeller shaft and crankshaft. To support the intermediate shaft there is intermediate shaft bearing. Okay, to support the intermediate shaft there is intermediate shaft bearing. Okay, construction and working means at aft portion of ship we have propeller, then propeller shaft which come inside the ship through a stern tube bearing. Okay, intermediate shaft, it is connects the propeller shaft and crankshaft. To support the intermediate shaft there will be intermediate shaft bearing also. Aft portion of the main engine we can see thrust bearing, and it is integral part of a main engine. Aft portion of main engine we can see thrust bearing, it is an integral part of a main engine. After the thrust bearing there is crankshaft which is supported by main bearing. After the thrust bearing there is crankshaft which is supported by main bearing. Main bearing and thrust bearing are supported by main engine bed plate which is bolted to ship hull. So, this main bearing and thrust bearing, these both are supported by the main engine bed plate which is bolted to the ship hull. Okay, the intermediate shaft bearing is also bolted onto ship hull. Stern tube bearing forms a part of the aft peak bulkhead. See, this intermediate shaft bearing which supports the intermediate shaft, that is also bolted to the ship hull, and a stern tube bearing forms a part of aft peak bulkhead. Okay, that aft portion of main engine we can see thrust bearing, it is integral part of main engine. After the thrust bearing there is a crankshaft which is supported by the main engine. So, main bearing and thrust bearing are supported by main engine bed plate which is bolted to the ship hull. The intermediate shaft bearing, it is bolted down to ship hull, stern tube bearing, and forms part of aft peak bulkhead. Okay, as the propeller rotates it will create a thrust which is called propeller thrust. As propeller rotates it will create a thrust known as propeller thrust which is taken up by propeller shaft and it is passed on to intermediate shaft. This propeller shaft is passed on to intermediate shaft. This happens because means propeller shaft and intermediate shaft both are connected together and thrust is further avoided by the thrust block. Okay, then thrust will be further avoided by the thrust block. As when the propeller rotates it will create a thrust known as propeller thrust which is taken by the propeller shaft and pass on to intermediate shaft. Okay, and this happens because the propeller shaft and intermediate shaft are connected together and the thrust is further avoided by the thrust block. Okay, the main reason why thrust block is placed at the aftermost part of ship is the crankshaft should be saved from propeller thrust. Okay, why the thrust block is placed in the aftermost part of engine means crankshaft should be saved from the propeller thrust. Main reason is crankshaft should be saved from the propeller thrust. The crankshaft at any cost should never be subjected to propeller thrust. We have to ensure that crankshaft should never be subjected to the propeller thrust. This thrust block has a thrust pad. Thrust block will be having thrust pad. When the propeller thrust is offered in ahead direction, these pads on the forward side of the thrust bearing take the propeller thrust. Thus, they do not offer any further motion of crankshaft. Here means thrust block have thrust pad. When propeller thrust is offered in the ahead direction, then these pads, that means on the forward side of the thrust bearing, they take the propeller thrust and do not offer any further motion of the crankshaft. When the ship is going in astern direction, these pads, that means after side of thrust bearing, take up the propeller thrust. So, the main reason for the thrust block is placed at the aftermost part of main engine is to protect the crankshaft from the propeller thrust. So that crankshaft at any cost should be saved from the propeller thrust because it should never be subjected to the propeller thrust. The thrust block there will be having thrust pad. When propeller thrust is offered in the ahead direction, that means forward side of the thrust bearing, then propeller thrust, they will thus do not offer any further motion of crankshaft when ship is going in crankshaft. When the ship is moving in astern direction, then these pads, that is astern means after side of the thrust bearing, they will take up the propeller thrust. This thrust pad will take up the propeller thrust. and transfer to ship hull. So the thrust pad absorbs the propeller thrust, and since propeller thrust pads are located inside the thrust block, which is bolted to the main engine bed plate, through the holding down bolts are bolted to ship hull and the ship starts to move. Here what is happening is thrust pad, they will absorb the propeller thrust, and since the thrust pad are located inside the thrust block, which is located to the main engine bed plate, through the holding down bolts are bolted to the ship hull, the ship starts to move. This is what happening. Thrust pad absorb the propeller thrust, since thrust pads are located inside the thrust block. So means thrust pad is located inside the thrust block, which is also bolted to the main engine bed plate. So holding down bolts are also there. So due to this arrangement, ship hull will start, the ship starts to move. So location where, to know where the location of thrust bearing means thrust block should be located. We have to understand that about nodes and antinodes. What is node and antinodes? Node means it is a fixed point where the amplitude of vibration is minimum or zero. Node means it is a fixed point where amplitude of vibration is minimum or zero. Antinode means it's just the opposite of node, means amplitude of vibration is maximum. Amplitude of vibration is maximum means antinode. It occurs, usually it occurs between two nodal points. Antinode will be there, just like a wave. Okay. Location means in order to find out the location of thrust block, we should know that node and antinodal point. Node means it is a fixed point where amplitude of vibration is minimum or zero. Node means amplitude of vibration is minimum or zero. Antinode means it is just the opposite of node. That means amplitude of vibration is maximum. Amplitude of vibration is maximum. Okay. Here it will, this antinode will occur between two nodes, and antinode will occur between two nodes. Then, so thrust block must always be placed at nodes, not at the antinodes. We have to ensure that thrust block should always be placed as nodes. That means amplitude of vibration should be minimum or zero. Thrust block can be placed at any nodal point along the shafting system. So we can say thrust block can be placed at any nodal point along the shafting system. Thus, it is always better to position the thrust block at nodal point where vibration is zero or minimum. So it is better to position the thrust block at nodal point where vibration is zero or minimum. Okay. Thrust blocks are fitted within engine. Thrust blocks are fitted inside the engine or outside the engine at immediate nodal point at the end of crankshaft. Thrust blocks are fitted within the engine or outside the engine at immediate nodal point at the end of crankshaft. Okay. Thrust blocks means they are usually placed at the nodal point, not at the antinodes, because it should be amplitude of vibration should be minimum or zero. The thrust block can be placed at any nodal point along the shafting system. So it is better to position thrust block at a nodal point where vibration is zero or minimum, like the explanation. Thus, thrust blocks can be fitted within the engine or outside the engine at immediate nodal parts at the end of crankshaft. A chain or gear drive for a camshaft is located at the nodes or near nodal point. Here, chain or gear drive for the camshaft is also located near the nodes or near nodal point. If the drive is taken from the nodal point, the turning moment will be even. So this is desirable as this will prevent any undue stress from being developed in the chain drive and get drive system. Okay. Chain or gear drive for a camshaft is also located near located at the node or near the nodal point. If the drive is taken from the nodal point, the turning moment is even. Okay. This is desirable as this will prevent any undue stress from being developed in the chain drive and get the drive system happen. Where to fit the damper and detuner? Okay, where we fit the damper and detuners? Let's also we need to understand that damper and detuners. We can see vibration curve in this diagram. Here the red line of the thrust block is located at the node or near the nodal point. Here we can see vibration curve with a red line. The thrust block it is located at the node or near nodal point, like I mentioned, because amplitude of vibration should be minimum or zero. In the same manner, vibration curve rises and damper is fitted at the antinode or near antinodal point. Here the vibration damper or they are fitted at the antinode or antinodal near the antinodal point, because there should be vibration should be maximum. In order to dampen the vibration, it should be fitted on the antinodal point or near the antinodal point. Okay. Then if the detuner and damper are fitted at nodes, they will not function effectively as the amplitude of vibration is minimum or zero. Yes, that's the main reason. If you place the detuner or vibration damper in a nodal point, they will not function properly because in the nodal point the vibration will be minimum or zero. So we have to place the detuner or dampers in a antinodal point where the vibration is maximum or near the antinodal point. If they are fitted at the antinodes, they will function effectively, but it is not practically possible to fit exactly at antinodes, thus often fitted at forward end of engine. Yes, that is what happens. Usually theoretically we can say they should place at the antinodal point, but practically we cannot exactly place the detuners or dampers at the antinodal point. So usually we will place it near the antinodal point. That is practically possible. We say we often fit at the forward end of the engine. Forward end of the engine we will place it. Then why can't the thrust block is located at stern tube? That's also a question we all have doubt. Thrust block, why can't we thrust block is located at the stern tube? If the thrust block it is placed near the stern tube, then there is less area for the propeller thrust to act on. Since the area is small, that we can say, because if thrust block is placed on a stern tube, that means the place near the stern tube there will be less area for the thrust to happen. We need some area, pressure and force to generate. Since the area is small, that means we require more additional stiffening members to withstand such huge thrust. And there is also one more reason, means number of nodal point available near stern tube is comparatively less. That is also reason. In the near stern tube, the number of nodal point, because near the propeller, so vibration will be very high, so nodal point will be less. So that's also a reason. Means if thrust block can't be located at stern tube, means if thrust block is placed near the stern tube, means there is less area for propeller thrust to act on. So very small area. So we require more additional stiffening members to withstand that huge thrust. There is one more reason, is number of nodal points that available near stern tube is comparatively less. So these 2 points, so that we can't place the thrust block located in a stern tube. When thrust block is placed near the main engine, the cross section area is comparatively larger for propeller thrust to act on, and it does not require any additional stiffening member. Thus thrust block form an integral part of bed plate itself. Here why we place thrust block near to the main engine, that is after the main engine, means because cross section area is comparatively larger for the propeller thrust to act on, and it does not require an additional stiffening member, as thrust block will form integral part of the bed plate itself also. So these are a kind of advantage when we place the thrust block near to the main engine. Then thrust force from the propeller when taken up by the thrust block located near the stern tube, they will have a lesser area to distribute the hull. So it means thrust force from the propeller when we taken up the thrust block located near the stern tube, they will have lesser area to distribute the hull. Yes, they will have less area, will be less, and number of nodal point is fewer near the, like I mentioned, number of nodal point will be fewer near the stern tube, and cross section area of ship near the main engine is large when compared to the area near the stern tube. Like I said, cross section area near the main engine is large when compared to that narrow aft end that near the stern tube. Thank you.